Welcome, curious minds, to another deep dive. Whether you're an AI developer looking to build smarter systems, maybe an investor keen on using cutting-edge research, or, just fascinated by the future of automated expertise, today's deep dive is definitely for you.
Yeah, we're tackling a really fascinating topic today.
We are. It's all about how to orchestrate like a team of specialized AI agents for complex tasks. We're using a detailed guide from OpenAI on building these multi-agent collaboration systems.
It's pretty cutting-edge stuff.
Absolutely. So our mission today is really to unpack how these multiple AI agents can work together, not just in theory, right, but with a clear blueprint for solving some really challenging problems. Think of it as, a shortcut maybe, to being well-informed about these leading-edge AI systems. We'll explore what multi-agent collaboration actually means, dig into the different ways AI agents can cooperate.
Like the different models they use.
Yeah, exactly. And then dive into a compelling real-world example, an investment research system. It's kind of like building an AI dream team, each member bringing their unique expertise to tackle something big.
Well, the real breakthrough here, I think, is moving beyond just a single monolithic AI trying to do everything at once.
Right. The one-size-fits-all approach doesn't always cut it.
No. Instead, we're talking about leveraging specialized AI nodes or agents that coordinate to achieve goals that would be, frankly, incredibly difficult for any one agent working alone.
That makes sense.
But it does beg the question, though, how do you design these systems so they're both really powerful and actually manageable?
Okay, so let's unpack that then. When we talk about this AI dream team, what exactly is multi-agent collaboration in the world of AI? Like fundamentally.
Yeah, simply put, it's when multiple autonomous AI agents coordinate their actions to achieve some overarching goal.
Okay.
So instead of feeding one massive complex prompt to a single AI, hoping it does everything.
Which often doesn't work that well for complex stuff.
Right, exactly. Instead, each agent handles a specific subtask, or maybe it has a specific area of expertise. And then there's an orchestration layer that connects these agents into a coherent workflow.
Ah, the orchestrator.
Precisely. And this approach is particularly useful for these really complex systems where, a single AI might struggle to maintain depth and accuracy across all the necessary domains.
So, okay, an example. Instead of one AI trying to do all the financial analysis for a stock,
right,
you'd maybe have one agent specializing in macroeconomics, another digging into the company's fundamentals, and maybe a third looking at quantitative signals.
Exactly that. They share information, their results get combined, and that produces a final output that's, far more robust.
I see.
And if we connect this to the bigger picture, for you listening, this approach gives you a powerful way to build systems that are transparent, auditable, and scalable, whether it's for research, analysis, or really any complex task that benefits from expert collaboration.
It sounds like it provides a clear blueprint for potentially building your own workflows.
It really does. It makes these complex problems feel much more approachable.
Okay, so when we talk about these agents collaborating, the OpenAI guide mentions a couple of key patterns. Can you walk us through those? I'm guessing it's not always the same setup.
No, definitely not. The OpenAI Agents SDK, which is what this guide uses, supports two main patterns. First, there's what they call handoff collaboration.
Handoff.
Yeah, where one agent can literally hand off control to another agent right in the middle of solving a problem.
Oh, interesting.
So each agent kind of knows about the others and can decide, okay, this part is better suited for the specialist over there. It's quite flexible, especially for maybe more open-ended or conversational workflows.
Oh, there's always a but.
Well, the potential downside is it can sometimes make it harder to maintain a clear global view of the overall task. Things can get a bit complex to track.
Okay, that makes sense.
Yeah.
And the other pattern, how's that different?
The second one, and this is the one used in the environment research example we're going to dig into today, is called agent as a tool.
Agent as a tool.
Okay. In this model, you have a central agent. Maybe think of it as a planner or a manager agent, and it calls the other agents as if they were just tools in its toolkit.
Ah, so the sub-agents don't take over the whole conversation.
Exactly. The main agent invokes them for specific subtasks, gets the results back, and then incorporates those results into its own process. It stays in control.
Right. Now that's where it gets really interesting for me. For a task like investment research, which needs to be pretty rigorous, probably auditable, why choose agent as a tool over the handoff method? What's the strategic advantage there?
That's a great question. The agent as a tool model really simplifies the coordination aspect.
Oh, so.
Because it keeps a single thread of control with that main central agent, the manager, essentially.
Okay.
So for complex analyses like this investment research case, choosing this model ensures the overall reasoning process remains transparent. You can see how the final answer was built.
Ah, traceability.
Exactly. And crucially, it allows for parallel execution of those subtasks. The manager can send requests to multiple specialist agents at the same time.
Which speeds things up considerably, I imagine.
Significantly. So it's really ideal when you need that deep specialization from your expert agents combined with robust auditable orchestration from the manager.
It's like having a project manager who assigns specific tasks to individual team members,
Precisely.
rather than the team members just passing the whole project binder back and forth.
That's a perfect analogy.
Yeah. Okay, sticking with that project manager analogy then. In our investment research example, how does this agent as a tool concept actually play out? What's the architecture look like?
So the system uses what they call a hub and spoke design.
Hub and spoke.
Right. The portfolio manager agent acts as the central hub, that's our project manager. And then the specialist agents, the ones focused on macroeconomics, fundamental analysis, and quantitative analysis, they're the spokes.
Got it.
So when you, the user, submit a query, it first goes straight to the portfolio manager agent.
The hub.
The hub. And this agent is prompted, programmed, to first break down the problem into smaller pieces. Then it delegates those pieces to the appropriate specialist agents, treating them just like callable tools.
Calling them up for their specific expertise.
Exactly. All three specialists do their work, report back to the portfolio manager, and then the PM agent synthesizes all that information into a single comprehensive final answer for you.
That sounds incredibly efficient, especially for complex analyses.
Yeah.
But I wonder, are there any particular challenges with that hub and spoke model? Especially if the underlying data changes really fast, or maybe you need a new type of analysis suddenly.
That's a really crucial consideration. And yes, while it's efficient, one challenge is making sure that central portfolio manager agent has robust enough prompting. It needs to correctly delegate and synthesize information even when the landscape is constantly shifting.
So the prompt engineering for that hub agent is key.
It's absolutely critical. But generally, the benefits seem to outweigh that challenge. I mean, you could ask, why not just have one giant super agent try to do everything?
Right. Why the specialization?
Well, overloading a single agent often leads to kind of shallow, generic outputs. It just can't maintain expertise across everything.
Jack of all trades, master of none sort of thing.
Pretty much. So by breaking the problem down into these specialized agents, each with a very clear role, you get much deeper, higher quality research. Each agent is focused entirely on its domain.
Makes sense.
It also brings modularity and clarity. You can update or improve, say, just the quantitative agent without messing up the macro or fundamental agents. That makes the whole system much easier to maintain and extend over time.
And I'm guessing faster results too, right? They're not necessarily waiting on each other sequentially.
Absolutely. That parallel execution is a huge advantage. Independent agents can work simultaneously, leading to much faster results.
How is that parallelism actually implemented?
In this specific system, they wrap each specialist agent, so it acts like a callable tool for the main PM agent. And the PM agent uses a specific tool actually called Runnel Specialist Parallel, which does exactly what it says. It invokes all three specialists concurrently for maximum speed.
Okay, very cool.
And another really powerful aspect here is the prompting. The agent's prompt, which is loaded from just a simple markdown file, doesn't just tell it what to do. It actually encodes the firm's philosophy.
The firm's philosophy. How so?
It sets out the preferred style of analysis, the level of detail required, maybe risk tolerance parameters, and detailed rules for how to use its tools. This isn't just about getting an answer. It ensures consistent, high quality, and importantly, auditable runs every single time.
That auditability piece seems critical, especially in finance.
Hugely critical.
So, okay, beyond just calling other agents, what other kinds of tools can these AI agents actually use? What's in their toolkit to interact with the outside world or perform calculations?
Right. That's another key advantage of something like the Agents SDK. The flexibility in defining the tools these agents can wield. And these tools can range from super simple Python functions you write yourself, all the way up to complex external services. In this specific investment research project, they use three main types of tools.
Here.
First, there's something called an MCP server, which stands for Model Context Protocol Server.
MCP server, what's that do?
Think of it as a standardized way for agents to connect to external tools and data sources. It's like a universal adapter. So whether the agent needs data from Yahoo Finance or maybe an internal company database or some proprietary API, the MCP server handles that connection in a consistent way.
So it makes plugging in different data sources easier.
Exactly. It makes the system incredibly flexible. In the example, they use a local MCP server just to grab Yahoo Finance data, but it could be anything.
Okay, that's one type. What else?
Second, there are OpenAI managed tools. These are powerful, built-in tools hosted by OpenAI that you can use right out of the box. Well, the big ones used here are Code Interpreter.
Yeah, very powerful for analysis.
It's hugely powerful. It allows the agent to run Python code for sophisticated quantitative and statistical analysis, data visualization, all sorts of things, without you needing to build that capability yourself. And they also use WebSearch for pulling in up-to-date news, articles, and other web data.
You get calculation and real-time info built in.
Precisely. These allow agents to perform pretty advanced actions without a lot of extra setup on your part.
And the third type?
The third type is custom tools. And this is really just any Python function that you, the developer, define yourself. The SDK makes it incredibly easy to register these functions as tools the agent can use.
You can add your own secret sauce.
Exactly. You can add domain-specific logic, maybe access proprietary internal data sources that aren't public, or just extend the workflow in any way you need. In this project, for instance, they have custom tools to access FRD.
The Federal Reserve Economic Data.
Right, for grabbing real-time economic indicators, and also simple tools for just performing file system operations, like reading or writing analysis files.
So this blend of tools, the standardized access through MCP, the powerful built-ins like Code Interpreter, and then your own custom functions, it sounds incredibly flexible. If you're thinking about building your own systems, what does this really mean in practice?
It means you're really not limited by some predefined set of capabilities.
Yeah.
You can tailor your agent's skills precisely to the problem you're trying to solve.
Tailor-made AI teams.
Exactly. Whether it's pulling in very specific financial data streams, executing complex, bespoke calculations, or scouring the web for real-time news sentiment, you have full control to extend your agent's capabilities far beyond just the built-in stuff. You can build truly bespoke and powerful AI solutions for your unique challenges.
Okay, now for the really exciting part, seeing this whole system in action. The source material includes an example, right? An actual investment memo generated by this multi-agent system.
It does, yeah.
What kind of tough question did they throw at it? And, maybe more interestingly, did any surprising or sort of counterintuitive insights pop out when the different specialists started digging in?
They gave it a pretty meaty question. It was, today is June 23, 2025. How would the planned interest rate reduction affect my holdings in GOGL Alphabet Inc. if they were to happen? Considering all the factors affecting its price right now, macro, technical, fundamental, etc., what is a realistic price target by the end of the year?
Wow, okay. That's not simple. That's multifaceted.
Absolutely. It's exactly the kind of complex question that would take a human analyst or even a team, potentially days, maybe even weeks, to research and synthesize comprehensively.
And the system did it. How quickly?
The implication is it compresses that process down significantly, potentially into minutes or hours, depending on the complexity and tool execution time.
Incredible. Okay, so let's look at the insights it generated. Starting at the top, the executive summary. What did the portfolio manager agent decide was most important to tell the reader right away?
Right, the exec summary. It highlighted that while, yes, a planned interest rate reduction is probably a mild tailwind for Alphabet, GOGL, which was trading around $171.42 in this hypothetical scenario.
Okay.
It's decidedly not the main thing driving its price.
Well, interesting. So rates aren't the key factor.
Not according to this analysis. The memo concluded that the real risk and reward hinges more on things like the sustainability of Alphabet's AI-driven growth, broader market sector rotation trends, and any potential regulatory headwinds.
So bigger picture stuff.
Exactly. And it specifically noted a surprisingly modest direct sensitivity to interest rates. It found the maximum weekly correlation between GOGL's price and the 10-year Treasury yield was only about 0.29. Pretty low.
That is lower than many might assume for a tech stock.
Definitely. Then it projected a best-case scenario for the stock reaching maybe $210 by the end of 2025, but it also gave a plausible worst-case retest of the $160, $170 level level.
Presenting scenarios, not just a single number.
Precisely. The output was really focused on scenario planning and providing original quantitative analysis, aligning with this hypothetical firm's vision, not just spitting out a simple consensus forecast.
That's a much more nuanced view than just rates down, tech up. What about the deeper dives from the individual specialist agents? How did their unique perspectives kind of build up this overall picture?
Yeah, the specialist sections added the real meat, so from the fundamentals perspective. This agent highlighted Alphabet's strong core business, driven obviously by digital ads, Google Search, YouTube, but also its growing cloud and AI segments. It pulled Q1 2025 numbers, revenue of $90.2 billion, net income $34.5 billion, EPS 2.81 cents. Pretty solid. And crucially, it noted that profit margins had actually improved, hitting 38.3% net margin.
Strong fundamentals then.
Very strong. And analyst sentiment backed that up. 56 buy recommendations, 12 holds, and 0 sells. So fundamentally, the company looked healthy and well regarded.
Okay, what about the bigger picture, the macro view?
The macro perspective agent painted a more mixed picture. U.S. real GDP was expanding, unemployment was low at 4.2%, but inflation was still elevated, with the CPI around 320.3. The Fed was holding rates steady in this scenario at 4.25%
So growth, but with inflation concerns.
Right. And interestingly, this agent flagged that investors seem to be rotating out of U.S. tech and into Asian equities, possibly reflecting concerns about high valuations in the tech sector.
So even if Alphabet's good, the sector might face headwinds.
Exactly. So while the company fundamentals looked good, the broader market context introduced a layer of caution.
And the quantitative agent, did it back up that low rate sensitivity claim?
It did, and this section was really key. The quantitative perspective firmly confirmed GOGL's modest direct sensitivity to interest rates. It calculated the mean weekly correlation with the 10-year Treasury yield at just 0.29, like the summary said, and the correlation with the Fed funds rate was even lower, a mere 0.05.
Wow, 0.05 is tiny.
Tiny. It directly contradicts that common assumption about tech stocks always being super rate sensitive. The quant agent also noted that the stock's technicals looked robust and momentum was positive.
But it also mentioned limitations.
Yes. Importantly, it acknowledged limitations, like having a relatively short data window, especially post-pandemic, which might affect the correlations. It really underscored that GOGL's price is driven by a whole host of factors, not just interest rates.
Okay, so you have strong fundamentals, a mixed macro picture with some rotation risk, and quantitative data showing low rate sensitivity but good technicals. How did the portfolio manager agent pull all of that together for a final conclusion? Did it end up leaning more optimistic or cautious?
The PM agent's synthesis resulted in what it called a moderately constructive outlook.
Moderately constructive, okay.
It converged on that realistic year-end 2025 price target range of $190 to $210. It really re-emphasized the point that GOGL's direct rate sensitivity is modest, and the real risks and opportunities lie in that AI growth story, the potential for sector rotation, and any regulatory issues that might pop up.
So reinforcing the key themes.
Exactly. It explicitly used the quantitative findings to support the robust technicals and positive sentiment, but also made sure to highlight that risk of a $160 or $170 retest in downside scenarios, which came from the quant analysis too.
And the fundamental and macro inputs.
They were used to underscore the importance of just monitoring things like regulatory developments and trade policy. It really aimed for a balanced view. So the final recommendation wasn't just buy or sell, it was more nuanced. Maintain or perhaps modestly increase exposure to GOGL, especially if you happen to be underweight large cap tech.
Right.
But, and this was strongly emphasized, pay close attention to position sizing and risk management to account for those different potential scenarios.
So a proper evidence-based scenario analysis, not just a simple prediction, aligned with that firm vision you mentioned.
Precisely. Focused on differentiated insight, not just echoing the consensus.
This has been a really incredible deep dive. We've gone from the core definitions of multi-agent systems all the way to seeing them tackle a complex real-world investment problem. For our listeners who are maybe feeling inspired now to build their own systems, what are the key takeaways, the best practices for building these powerful AI teams effectively?
Yeah, I think the most effective systems we're seeing really combine a few key things. That modular agent design we talked about, having very clear tool definitions, leveraging parallel execution for speed, and using highly structured, detailed prompts.
It's the combination that matters.
It really is. And the true power comes from how frameworks like the OpenAI Agents SDK provide these crucial building blocks. Think about the agent loop. It's not just automation. It's like this quiet background engine that lets these incredibly complex multi-step processes run autonomously.
Yeah.
That frees up the human experts for higher level strategy and oversight.
Takes the grunt work out.
Exactly. And then something like tracing. That's not just for debugging code. It gives you a fully auditable chain of decision making. You can see exactly which agent did what, with what information, and why. That's revolutionary for fields like finance or healthcare, where compliance and explainability are paramount.
Absolutely critical.
And then you add in the other features. Python-first orchestration makes it easier to chain agents together and compose complex workflows in handoffs, if you need that flexibility. Guardrails help ensure reliability and prevent unwanted agent behavior. And those function tools let you plug in literally any Python function you need. It all provides the scaffolding for building really robust systems.
So it's a toolkit for building these sophisticated collaborators.
It is. And ultimately, it's that combination of well-designed tools, thoughtful orchestration logic, and of course, careful selection of the underlying AI models in this case. They use the GPT 4.1 family, likely for their strong analytical and tool use capabilities. That's crucial.
Right. The model choice still matters.
Absolutely, but putting it all together using this kind of approach leads to systems that aren't just powerful, but also robust, scalable, and, importantly, much easier to debug or extend later on compared to one giant monolithic system. And folks wanting to go deeper should definitely check out resources like OpenAI's A Practical Guide to Building Agents for more implementation details.
Great suggestion. So we've really journeyed from the theory of multi-agent collaboration to seeing it produce this remarkably detailed investment report.
Yeah.
Stepping back, what stands out to you as the biggest takeaway from this whole deep dive into building AI teams?
What truly strikes me is how this kind of framework empowers you, the builder or the user, to move beyond just simple AI interactions like asking a chatbot a question.
Right, it's more than Q&A.
Much more. It's about actually constructing these complex, specialized, and auditable AI teams that can tackle virtually any intricate problem you might face. It really shifts the perspective. It's not just about one AI finding an answer, but about orchestrating this symphony almost of expert insights to deliver really comprehensive, nuanced solutions.
A symphony of expert insights. I like that. And that, I think, raises an important final question for you, our listener. Given the power of these orchestrated AI teams we've discussed today, what complex problem in your own work, or maybe your field of interest, could benefit most from this type of multi-agent collaboration?
Where could you apply this?
Something to mull over until our next deep dive.